Hi students, welcome back to Wisdom Academy YouTube channel. In the previous video, you have learnt about the electric lines of forces. Today we will see the next topic, that is electric flux. So if you see the word only flux, then what do you understand by flux? This is not a new word for you. It is just an English word which means flow of anything. So air passes through an area, it is called as air flux. If water is passing through a particular area region, it is called as water flux. Same way, electric flux has something to do with electric field, right? So flux is a measure of any vector field. So electric flux is the measure of electric field, that how many electric lines of forces are passing through a given area. To be very specific and to be very to the point to the equation, it says that electric flux is the electric lines of forces passing through a given area kept normal to the electric field. What I am meaning, suppose there is electric field like this is the electric field and this is some area, let the area be ds. So we must see how many lines of forces are passing which are normal to the area. So if this is the area, suppose this is the area, what will be its normal component? This will be its normal component. I write n cap as the direction of it. So I want to see electric field and n cap. Always the electric field should be in this direction, in the n cap direction, that is normal to the area. So here this is the n cap and luckily E and n are in same direction. So I can write the electric flux phi E is equal to E into electric field into ds. If you want to write the vector quantity, this will be E ds n cap, right. Now this is a simple condition. What if through a particular given area the electric lines of forces are not passing normal but passing with some angle like this? It is quite possible that they are passing through some angle, let that angle be making theta with the normal. So this is the normal, this is the direction of electric field. So electric field is making some angle theta with the normal. Then what will happen? In that case, we must consider only the normal components of the electric field. So if this is E, this is theta, what would be the normal component of electric field here? That will be E cos theta, isn't it? Because this is theta, this will be, that will be E sin theta, it will be E cos theta. So in this case, what will be the flux? Phi E will be equal to E into, or I write E cos theta into ds. I can write like this. So I can write phi is equal to E ds cos theta. We know that A vector dot B vector is equal to AB cos theta, isn't it? So here also it was a vector quantity. So I can write here that phi E is equal to E dot ds. So the exact equation of electric flux is E dot ds, that is electric flux vector is equal to electric field vector dot product of area vector, and direction is always n cap. So keep that in your mind. What will be the SI unit of electric flux? So its SI unit will be what? SI unit will be, what is the SI unit of electric field? Newton per coulomb. Newton per coulomb. What is the SI unit of ds? Meter square. So it will be Newton coulomb power minus 1 meter power 2. You will also learn that this is equal to voltmeter. How this voltmeter comes, you will know only in the next chapter when you learn about what is potential. So remember, SI unit of electric flux is Newton per coulomb per meter square, or that is also equal to voltmeter. This is about the SI unit of electric flux. So once again, if I repeat you, electric flux is the electric lines of forces passing normally through a given area. You can add this definition, and numerical value of electric flux is E dot ds. Next we are going to talk about Gauss law. Gauss gave us a relationship between the total flux passing through a closed surface and how much net charge it encloses. I will repeat once again. Gauss gave us a relationship between what is the total flux passing through a closed surface and how much charge is getting enclosed inside that surface. So remember that Gauss law is applicable only on any enclosed surface. It should not be open surface, it should be enclosed, right? So what did Gauss say? Gauss said that total flux passing through any closed surface is 1 by epsilon naught times the net charge enclosed. I will repeat once again. Total flux passing through any enclosed surface is 1 by epsilon naught times the net charge enclosed. If I write it mathematically, he said phi, electric field phi is equal to E ds, integration of E dot ds, and that is equal to 1 by epsilon naught times the charge enclosed. Suppose the charge enclosed q, so q by epsilon naught, right? This was the mathematical expression of Gauss law. If in exam they ask you to prove the Gauss law, yeah, you can prove it. For proving it, let us have a charge. Let me take a positive charge here. So I said you to apply the Gauss law, we must enclose it. Now someone may ask me how to find the enclosing. So how the surface should be? That surface is known as Gaussian surface. The surface which encloses any charge. In this case, if I am drawing a sphere, then the sphere becomes a Gaussian surface. Now, how to decide what will be the Gaussian surface? It is purely based upon your judgment, by your cleverity, how much clever you are to choose the best Gaussian surface which gives you minimum trouble in solving the problem. So, Gaussian surface is not any hard and fast surface, it is purely based upon a judgment. So, in this case, I have positive charge, and we know positive charge, it is having electric field radially outwards, right? Last class we saw that. So, I have drawn a Gaussian surface which is spherical in nature. So, remember that this is a spherical Gaussian surface like this. It is a spherical Gaussian surface. Now, what I will do, on this Gaussian surface, I will take any particular small area. Let me name this area as ds, small area ds, right? So, what I am going to do now, at this point ds, let me keep the charge on the center of this sphere and let the distance be r. Okay, I know this is a charge q, so I know that by my knowledge of electric field, what will be electric field at ds? If I want to find what is the electric field at ds, so what will be that be? E will be equal to, I am writing the magnitude of electric field, that will be equal to k into q by r square, isn't it? Kq by r square will be the magnitude of electric field. What will be its direction? Direction of electric field will be radially outwards. It will be radially outwards. Now, let me apply the equation of electric flux. I know electric flux phi is equal to E dot ds, or to be very specific, E ds cos theta. Here, what is the angle between the normal component and the electric field? This is the electric field, right? And this is the normal component n. They both have angle as 0. So, since theta is equal to 0 degree, I can write phi is equal to E dot ds, right? This is d, I am writing it as d phi. Why I am writing d phi? Because it is the small flux passing through only the small ds area. I want to find total flux, I will integrate on both sides in the total limits. So, 0 to phi, and here I will integrate from 0 to s. I will write total surface integral. This is also called as surface integral. So, I can write here directly s, surface integral. So, this will be phi. So, phi will become equal to E into integration of ds, surface integration of ds. So, what is the surface integration of ds? If we take the total surface, it becomes a sphere. So, I can write here phi is equal to E. So, what is the surface area of sphere? It is 4 pi r square, 4 pi r square. I will put the value of E. E is kq by r square, and k is actually 1 by 4 pi epsilon naught into q by r square, and already 4 pi r square is there. So, 4 pi gets cancelled, r square gets cancelled. I get total phi is equal to q by epsilon naught. This is the exact definition what was given by Gauss. So, Gauss said that total flux passing through any enclosed surface is 1 by epsilon naught times the net charge enclosed, and by this positive charge we have proved that phi is equal to q by epsilon naught. Now, let us see one question based upon electric flux. The question is, if E vector is equal to 6i cap plus 3j cap plus 4k cap, calculate the electric flux through a surface of area 20 units in the YZ plane. 20 units in the YZ plane. So, now to have a clarification over this, I will draw a coordinate axis which is x, y and z. So, what they are saying, the surface area is in YZ plane. So, what is the meaning of YZ plane? You know, this is y, this is z. So, plane YZ plane will be represented like this. This is YZ plane. So, normal to YZ plane means this is normal, isn't it? So, what is the direction of the ds? It is in x direction. I hope you know that x direction, the unit vector is I cap, here it is j cap and here it is k cap. So, I can write from here that ds vector is 20 I cap. I hope you understood how I wrote is 20 I cap. How I wrote? Because they have given the magnitude as 20 units and they have told the area is in YZ plane. So, it is passing through YZ plane. So, YZ plane will have normal in this direction, and already they have given the value of electric field. Electric field is 6i cap plus 3j cap plus 4k cap. So, what will be phi? Phi will be equal to E dot ds, right. So, what is that? E dot ds? E vector is 6i cap plus 3j cap plus 4k cap, and what is ds? Dot ds is 20 I cap. So, what is the dot product of these two things? I hope you remember dot product. I cap dot I cap will be 1, j cap dot I cap will be 0 and k cap dot I cap will be 0. So, only these two will go in multiplication and I will get 120 units. So, the value of electric flux is 120 units. Very basic question, just to give you a clear understanding about the ds I used this. Let us see one more question. This question has been taken from NCERT. The question says like, the electric field components in figure are Ex is equal to alpha root x, Ey and Ez is equal to 0, in which alpha value is given as 800 Newton per coulomb meter square. You have to calculate the net flux through the cube and charge within the cube. So, in this question if you see, they have given the value of Ex. So, in this x direction the value is given, Ex is given, that is alpha root x, and Ey and Ez there are no values, right. So, they are asking you to find what is the net flux through the cube. One thing, in this cube there are how many sides? There are 1, 2, 3, 4, 5, 6 sides are there totally. So, and this cube is having, any cube will have 6 sides. So, now these 6 sides, if I take this as the first side and this side as the second side, why I am taking these two sides? See, remaining all the sides, I am talking about this side or that side, this side or this side, everything will have theta as 90 degree, isn't it? Because we know that phi is equal to E ds cos theta. So, in all the other faces, since theta will be equal to 90 degree, let me name the face as, let this be 1, let this be 2, let this be 3, let this be 4, let this be 5 and let this side be 6. So, theta is equal to 0 degree in which faces? In face number 3, 4, 5 and 6. So, all these faces theta will be 90 degree, isn't it? Because see, this is the value of electric field, face for above if I say this is the direction. So, angle between them is 90 degree. Same way for third thing, this is electric field, this is the direction. So, angle between them 90 degree. Same way here also 90 degree. So, in all the places you get the angle as 90 degree, and so E ds cos 90 is 0. So, phi for third phase, that will be equal to phi for fourth phase, that will be equal to phi for fifth and for sixth, and everything will be equal to 0. So, we need to worry about only two phases, first phase and second phase, and we have to find the value of phi for those, right. So for finding the phi for those, we want to find first electric field to that, because electric field is a factor of alpha, and alpha is different for x, and x is different for both the cases. Here the x value is a, here the x value will be 2a. So I need to find what is the electric field for the first plane and electric field for the second plane. So for the first plane, electric field will be alpha into root what? A. Why? Since x is equal to a at that point. Same way, what will be at this point, second point? It will be alpha root over 2a, because x is 2a, since x is 2a here. Then let us see what will be the value of phi. So phi for the first phase will be equal to E1 into ds I will take for 1 into cos theta, E ds cos theta. So what is the value of E? Let it be even now, later I will add, or if you want to write even here, alpha into root a. What is theta here? Theta ds will be equal to, area is a into a square, right? And what is cos theta? Theta is, in this case, is 0 degree. Sorry, see here the normal area is on this side, n vector, and electric field is on that side. So theta is 180 degree, so cos 180 degree. What is cos 180 degree? Minus 1. So I will get here the value as alpha, here a power 1 by 2 and here a power 2, 2 plus 1 by 2 will be 2 plus 1 by 2, it will be 5 by 2. So I will get the value of alpha as alpha into a power of 5 by 2. Minus will come here. Why minus is coming? Because cos 180 is minus 1. This is the value of phi 1. So I got the value of phi 1 as minus alpha a power 5 by 2. Similarly, what will be phi 2? So phi 2 will be equal to E2 ds2 into cos theta. This is the second phase. So for the second phase, what is the value of E2? Alpha into root 2a. That will be equal to alpha into root 2a. What is ds? Again a square. And what is the theta? This is the n vector, isn't it? And this is ex vector. So 0 degree cos 0. That gives me phi 2 value as, so here if you see root 2 times of alpha, again root a and a square, that will be equal to a power 5 by 2. So root 2 into alpha into a power 5 by 2 is the value of phi 2. So what will be the net phi? Net phi net will be equal to phi 1 plus phi 2, that will be equal to, if I take a power 5 by 2 as common, then alpha also comes common, then it will become root 2 minus 1. So when you solve this equation by putting the values of everything, so here we know that the value of alpha is given as 0.1. So you put the value of alpha, you will get the answer of phi. In terms of what is the unit of phi? It is Newton c power minus 1 meter square. This is how I get the answer for the first part. So if you solve this, you will get the answer. Second part says that charge within the cube. Now you can use Gauss law. Gauss law says that phi is equal to q by epsilon naught. I got the value of phi from here. So what will be q? Q will be equal to phi net into epsilon naught. So phi net value we can use from here and put, and what will be the value of epsilon naught? That we know it is 8.85 into 10 to the power minus 12. So when you solve this, you will get this much coulomb as the charge. This will be the answer of the second part. So this is how we solve this question. So in today's class, what we learned? We learned about electric flux, its definition. We learned about Gauss law and what Gauss law says. Then we derived the Gauss law by the help of a single positive charge, and then we solved few numericals based upon electric flux, which is very important for the school examinations. One thing, I think in the beginning somewhere on the flux I made an arrow. Is it correct? I don't think, because flux is a scalar quantity. Flux is a electric flux will be a scalar quantity. How it is scalar quantity? Very simple. Since it is a dot product of two things, you know that if it is a dot product of any two things, it will be a scalar quantity only. You have studied in 11th standard. Dot product of two vectors is always a scalar, isn't it? So the flux is a scalar quantity, not a vector quantity. Keep this in your mind. I am just telling it at the end because somewhere, if I am remembering, I have told that phi, I have put arrow over that. That is not correct. It is a scalar quantity. So, phi is a electric flux is a scalar quantity. So, with this I will wind up. In the next video, you will learn about the application of Gauss law. That is the last topic of this chapter. I hope you are practicing the questions from your textbook. If not, then nothing is going to work for you. Please start solving the numericals given in your textbook, whatever it may be. Thank you very much.